hope you had an awesome spring break. I'm back with more math for you today. So grab your pencil and your book and we'll get started. All right, so let's start up here with our daily math. And today the strand of math that we're working on is called patterning and algebra. So all they're asking you to do is look at all of these equations and make sure that they are complete. And then they're asking you to make one pattern. So we'll start with number 1, and it says complete the following equation. Now in grade 3, you learned that, well, actually in all grades, but in grade 3 we really practice this. When you see this equal sign, you imagine it's like a balanced scale. So whatever is on this side of the scale has to also be on this side of the scale. This equal sign just means that it balances, it's the same. So 12 plus 10 is 22. Whatever is on this side of the equation needs to be 22 too. So we already have 15. We started at 15. Let's count up to 22. 15, I'm going to count up 5 to get to 20. And then I'm going to count 2 more to get to 22. So I counted, 15, 20, 21, 22. I counted 5, 6, 7. Now you can check your work. 15 plus 7, add them together and make sure that they make 22. So 15 and 7 is 22, and 12 and 10 is 22. This balances now because I have the same amount on this side of the equal sign as I do on this side of the equal sign. Okay, let's go to number 2. Complete the following equation. So same thing. We're doing the exact same thing. We're balancing it out. So on this side of the equation, it equals that much. So on this side of the equation, it has to be the same. So looking here, 5 and 2, use your facts here. 5 and 2 is 7. Okay, so on this side of the equation, it has to equal 7. So 6 plus, right, 1. 6 plus 1 is 7. They both balance now because there's 7 on both sides of our scale. Our scale is equal. It is balanced. This little equal sign, that's all it means. Okay, now it's asking you to complete the next equation. So complete the following equation. It's 25. Oh, sorry, I'm moving my paper around too much here. So on this side of the equation, 25 plus 6 has to equal the same as this side of the equation. Now this is subtraction, so it gets a little more tricky to think of because you have to think in the opposite, but that's okay. So 25 subtract 6 is going to be 19. Right, so 19. So I look on the other side of my equation. What subtract 11 is going to equal 19? So what's 11 plus 19? It's an easy way to find it out. Just do the opposite. So 11 plus 19, add 1, 10, 21. Add 9, 30. So 30 subtract 11 should equal 19. So 19 on this side and 19 on that side. So you just did some algebra right there. You're finding this missing number, and you can always do the opposite operation. So we did, instead of subtraction, we added to find out what this mystery number would be. But however you decide to figure it out works, just as long as you know both sides are equal. Both sides equal to 19, right? Because this equal sign is just like a balance scale. Okay, so it says complete the following equation. Now same thing, 89 comes first. We know on the other side of this equation, we need to have 21 has to add to 89, right? 21 plus something is going to be 89. Now, in this question, I used the opposite operation to find the answer, so why don't we do that here? So 21 plus something is 89. If I do my total, 89, and I subtract 21, that should tell me what's missing from here. So let's do that subtraction. I'm going to use Grandpa's way. 9 subtract 1 is 8. 8 subtract 2 is 6. So it's actually 80 subtract 20. Those are tens. So 68. So 21 plus 68 is going to equal 89. And this already equals 89. So on both sides of our equal sign, it's balanced. So I know sometimes when we're doing math, you think when you see that equal sign, it just means, give me the number, give me the answer. That's not actually what it means. And when you start to realize that this is a balance sign, that's going to help you with the math that's coming at you when you're older. So knowing this is actually the foundation of knowing algebra. And algebra is one of my favorite things in math. So you just did some algebra. Congratulations. That means you're finding for an unknown number. That's all it means. Same with mashup math. That's also algebra. Okay, so now it's just asking us to create a repeating pattern. And you can do anything you want for that. I think we had a repeating pattern last week, but a repeating pattern isn't increasing. It's not getting bigger. The numbers aren't getting bigger. It isn't decreasing. The numbers aren't getting smaller. The numbers are staying the same. So I could have 8, 5, 8, 5, 8, 5, and that would be a repeating pattern. Now I'm going to do another repeating pattern just for fun, and I'm going to use, let's go with, I'm going to roll my dice to find my numbers, because why not? So I'm going to grab my dice, and we're going to make a repeating pattern so my first number is 3. So my second repeating pattern, you don't have to make 2, but I'm just showing you what a repeating pattern is. Okay, and my next number is 2. And then I roll the dice, and my next number is 1. Awesome. So if I want to make 3, 2, 1 a repeating pattern, I go 3, 2, 1. Now I need to repeat it. 3, 2, 1. What would come next? That's right. We're repeating this pattern. 3, 2, 1. And that would just repeat on and on and on and on. So this is a repeating pattern with 2 elements. So let's remember when we were in grade 1 and kindergarten, we learned patterns can be with letters too. So I'm going to just show you a little mini lesson here. So this one would be with 2 elements, and let's call those elements A, B, A, B, A, B. Remember how patterns can have letters? Now for this one, my first element is A, and then B, and then C. And then I start over again at A, B, and C. And over again, I'm repeating pattern. A, B, and C. All right, so that's a little mini lesson on patterns. Remember, it's not increasing, it's not decreasing. If it's increasing or decreasing, the numbers change, but this is a repeating pattern, so we can name it with the letters if we want. Repeating pattern just repeats. So imagine you're playing your favorite song on whatever your music streaming service is of choice, and you press the repeat button, and the song just plays over again, and when it's done, so here's my song, ABC. When it's done, it replays ABC, ABC. All right, that's enough about patterns. Now, we're gonna move on to a problem, and to try something different today, I've prepared some counters to kind of illustrate this. So first we're going to read the problem. So the problem is a fire department put out 25 fires. Sorry, it's a bit less shadows if I put my pen down here. So let's start over. A fire department put out 25 fires last month. 2 out of every 5 of the fires began in the kitchen. How many of the fires did not start in the kitchen? So we know, I'm going to write down my important information on a sticky note because I'm going to use a different page to help me here. So what do we know? We know, let me get my handy dandy marker here. We know that there were 25 fires. Okay, so I'm going to write it on my sticky note. You don't have to do this because you guys might not be working the same way I am, but this is going to help. Sorry, I forgot how to write. 25 fires. 2 out of every 5 fires started in the kitchen, okay? Now imagine, actually I'm going to do a little bit of counting here. So I have 5 fires. So these 2, I'll grab my other paper here. 5 fires, 2 in the kitchen, and then 3 outside the kitchen. Hold on, guys. So we're going to build this problem to illustrate it, because it's a little bit of part whole. So we're doing parts of the whole, and I'll explain what I mean right away. So let me get my important, I know I probably lost half of you right there. Sorry about that. I just had a really good idea of how to explain it right in the middle of when I was explaining it. So 3 out of 5 fires, not kitchen. And I'm going to explain that with counters right away. You're thinking, well, how did you know that? Okay, so not kitchen. Okay, so I'm going to bring this piece of paper over here, and it's going to help me explain it a little bit more. So say that these are our 5 fires, okay? And we know 2 out of those fires start in the kitchen, so I'm going to give them a K. Now I have 5 all together. That means to make the rest of the 5, we don't know. I'm just going to put question marks because we don't know where they started. But 2 out of my 5, here's my 5 fires, right? They told us. Grab my thing here. I have 25 fires. 2 out of every 5. So here's 5 start in the kitchen. And then we have 1, 2, 3 not in the kitchen. Our question is asking us to figure out how many fires did not start in the kitchen, okay? So that's all we have to figure out. We have 3 out of 5. Now it told us there were 25 fires. So we're gonna move these out of the way. And the easiest way to think about this is to break it into groups of 5. So we have 25. How many groups of 5 are we gonna need? So let's count. 5. Some of you may already be screaming out the answer. 10, 15, 20, 25, right? So I have five groups of 5 to make my 25 fires. So I have 25 fires. Don't get confused, guys. 25 fires. Let's count. 5, 10, 15, 20, 25. We know 3 out of every 5 were not in the kitchen. So 3 out of 5 weren't in the kitchen. 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 Right? So now all we have to do to find out how many fires weren't in the kitchen is just count up our 3s. So 3, you know how to count by 3s, right? Let's try. 3, 6, 9, 12, 15. Now 3 times 5 is 15, so that makes sense. So I believe we have illustrated, let's just double check that. We have 25 fires, 2 out of 5 start in the kitchen. We're not actually worried about that. We don't care how many start in the kitchen because we need to find out how many started not in the kitchen. We know there's 3, and we know we're gonna have 5 groups of 5. 3, 6, 9, 12, 15 fires. And that's the same as, I just thought I'd do it a little differently than just writing it down, but so we know that there's 3 out of every 5, and we know there's gonna be 5 groups of 3, so 1, 2, 3, 4, 5 equals 15. So 15 fires. And I hope that my building the problem was a different way of looking at it. I realized last week you guys were just looking at me do a lot of adding. Sometimes it's good to see the problem built. If you prefer to write it out in numbers and add it yourself or even do it in your head, that's cool. But just seeing it broken down in that way, I hope it helped a little bit. So we know, we look at the set, right? The sets of 5, and that's what we did. Okay. On to the next part. I'm not going to do any more talking about our problem of the day because I'm sure you're all going, okay, Mrs. Oakes, I get it. So it's asking me to color a circle now. So I'm going to color this circle. I'm just going to cover up this so that it's not distracting you. Okay, and now we're going to color the circle according to the directions. So it's asking me, so I'm just going to move my Harry Potter book a bit so you can see it all. It's asking me to color the fraction. So let's read what it's saying. It says color half of it orange. Okay. Color 1 part purple. Color 1 part brown. So that brown looks very similar to orange. Let me grab on camera. It didn't look that similar when I was looking at them, but now that I'm seeing them on camera, wow, those look the same. So I'm gonna grab a different orange or brown. So this is my brown. That should be a little easier to see. Okay, so now I'm gonna color them. So half of the circle is orange. So half is just where I break my hole into 2 equal parts. So I have 1 part here and 1 part there. Half is actually 2/4. So half is orange. I'm gonna color it in. Okay. Now 1 part is purple. Purple! Audrey would be really excited right now if she saw me coloring with purple. That's her favorite. Okay, and then my last color is brown. These are lovely fall colors. Actually, they go together quite nicely. Sorry, your coloring's probably neater than mine. Okay, so now I've colored my circle. I'm going to name my fractions. So I have a total of 4 pieces. 1, 2, 3, 4. And I know the total number of pieces is the number that goes on the bottom. So it's out of 4. How many pieces out of 4 are orange? 1, 2. 2 out of 4 are orange. Another way to write that is also to write 1/2, right? Because they even said half up here. All right, let's go on to the next one. What fraction of the circle is purple? So again, I know I have 1, 2, 3, 4 parts. So the part that goes on the bottom, because I have 4 parts, and I have 1 out of the 4 parts is purple. Now it's asking me what fraction of this circle is brown? And I have 1, 2, 3, 4 parts. Okay, and there's 1 of those parts is brown. So 1/2 or 2/4 or 2/4, 1/4, 1/4, 1/4, 1/4. There's different ways to say these fractions, but they all mean the same thing. All right, I hope that was helpful. Let's go on to the next page. Now for this page, we're reviewing something that we have been working on for a while now, but I still notice a lot of us see this division sign and we sometimes freeze. So we're practicing this even if you don't freeze. This is a good practice for you too. So we're gonna go through these one at a time. And what I'm gonna do is I'm gonna do the first row with you and then I'm going to let you go for it. Okay, you're going to finish this and you're going to check your work. So I'm going to go through the first couple rows, explain what to do, and then I'm gonna pause the video. At the end of this, after I'm done the pause, I will put a picture up of the completed sheet so you can see the answers. You can pause on that picture of that shot of the completed sheet. But I want you can pause your video so you can check the answers. But before you do that, I really want you to try this, okay? Because this is an important skill, and most of you have got this down but could still practice it. So let's practice together. So I look here, and I'm going to start with my first one, 24 divided by 8. So I think to myself, what times 8 is 24? Think about it. Right, 3 times 8. So 3 times 8 is 24. You don't have to write this. 24 divided by 8 is going to be 3. Okay, for my next one, I'm actually going to get a whiteboard here to help explain it. My next one is 21 divided by 3. So I have 21. And all I have to do to find the answer is rearrange my numbers. What times 3 equals 21? Well, Mrs. Oakes is one of my favorite facts. For multiplication, it's actually 7. 7 times 3 is 21. So if 7 times 3 is 21, then 21 divided by 3 is 7. So again, I go, okay, I know this one. 21 divided by 3 is 7. Okay, on to the next one. 100 times 10. 100 times 10. So I would go and I'd think, okay, sorry, 100 divided by 10, not times 10. 100 divided by 10. Okay, or something times 10 equals 100. So what times 10 equals 100? Think about it. Think about your facts. Right, 10 times 10. 10 times 10. So I know you don't have to write down the multiplication part, but know that you're going to get this answer by figuring out what times 10 equals 100. Because like we practiced last week, when we do multiplication and division families, remember I drew the house over the fact families? When we do multiplication and division families, they use the same numbers. It's just the same numbers over and over again. So they're using the same numbers in this family. We're just rearranging them to make so that they make sense, almost flipping them. Okay, so let's go through this one. 100 divided by 10 is 10. Okay, I'm going to write out the next one. 9 divided by 3. So think of it this way, guys. And again, if you know your facts and this is coming easy, awesome. I can tell you've been practicing. If you're really struggling to find your facts, then that tells you you need to practice your multiplication facts. Okay, 9 divided by 3 is something. 3 times what equals 9? That's going to give us our answer. Think about it. 3 times 3 equals 9. Okay, I'm going to do one more row of these with you. If you have got this and you're sick of hearing my voice, I totally get it. You can just pause the video and work through the rest of it. If you're getting this and you're thinking, I could use a couple more explain to me, Mrs. Oakes, please explain them, then tune in because I'm about to do these 4 right here. We'll work through them together and then I will let you work on your own for a while, okay? So we're gonna do these 4 together right now. So my first one is 15 divided by 5. So 15, and if you want to write it out, if that helps you, sorry, was it divided by 5? Yep, divided by 5 equals something. Well, 5 times, this is actually a little bit more algebra for you guys, believe it or not, just in multiplication form. So 5 times something is 3, same as 5 divided by 5. So what, oh sorry, I just gave you the answer. 5 times something is 15. Oh, it's very early in the morning when I'm filming this. I haven't quite woken up yet. So 5 times something is 15. 5 times, I just gave you the answer, 3 is 15. So 15 divided by 5 is 3. So you could go to your question. 15 divided by 5 is 3. All right, 16 divided by 4. So let's do it. 16 divided by 4. 16 divided by 4 equals something. So to figure that out, I think in my head, again, this could be in a thought bubble because you don't have to write it down. So I'm thinking in my head, 16 divided by 4, well, 4 times what equals 16? So you're thinking 4 times what equals 16? If you're really stuck, grab a multiplication table and that can help you. 4 times 4 equals 16. So 4 times 4 equals 16. So that means 16 divided by 4 is going to be 4. Okay, and I have grabbed my pen here. Got a lot of pens on the go. All right, 30 divided by 5. So I'm going to model the process again. Again, if you're getting sick of this and you're like, I get it, pause the video and go work on your own. That's okay. It's the beauty of me being virtual. So 30 divided by 5 equals, and we're going to think in our head, right? I'm putting a thought bubble because this is what you're thinking in your head when you see a division. You think, what times 5 equals 30? So 5 times what equals 30? So you could figure that out by counting by 5s or thinking of your facts. Okay, so think about it. 5 times what is 30? So think, how many groups of 5 are 30? Right, it's 6. And let's check our work. 5 times 6 is 30, so that tracks. Okay, 6. And now we're going to do our last one together before I pause the video and let you work through this on your own. So just give me a sec here. 12 divided by 4 is my next one. So I go 12 divided by 4 equals my mystery number, right? The number I'm trying to figure out. So in my head, think in a thought bubble. 4 times what equals 12? So think in your thought bubble. 4 times what equals 12? 4 times what equals 12? Think about it. Right, 4 times 3. 4 times 3 equals 12. So 12 divided by 4 is 3. Okay, so I worked through those step by step. If you are really stuck and you're going, I can't remember my facts, that is a sign to you that you need to practice. Don't despair. Remember that we all start somewhere and we all have to practice those facts to get them to a point where they make sense to us and they come when we need them real quick. So you'll get to a point where you'll look, oh, I know that one, I know that one, I know that one, I know that one, because you practice the facts. Your brain has to create those new pathways, guys. So if this is really hard for you, I want you to put aside some time today to practice those facts, okay? So right now I am going to tell you to pause the video, and then when you come back, when you're done, I will show a screenshot of the completed sheet, or just a shot of the completed sheet, and you can pause the video on that shot and get the answers to mark your work. Okay, so pause the video right now, work through these using the same, think of multiplication, right? So it says right here, for an example, think, what can I multiply by 4 to make 20? They even put the thing that you should ask yourself in your head right there. Okay, so work on that right now. Pause the video and come back to check your work. I'm here.